you would like to ask a question, please unmute the mic, ask your question, and then mute your mic again so that we can control the background noise. Um, this is being recorded, so if you have an issue with that, please go ahead and hide and shut your video off so that you will not appear in it. So we're beginning again at the beginning. My name is Maudie May. Now, I know that I bear a striking resemblance to my cousin, whom you all call Malkin. I call Malkin a pretentious pain in the pants. This class is going to be part story time and part show and tell. It's mostly aimed at teaching the cabin boys, so I apologize in advance for any oversimplification. The first person I could introduce you to, if I could introduce you to a person, would be Gracie O'Malley. Gracie O'Malley was a very famous female pirate. And there were, indeed, female pirates. She was an Irish female pirate. Now, piracy was one of the first equal opportunity employers. We have records of 2000 BC. There are stories of women in China who served aboard sailing vessels and participated in the work of sailing. So here's the thing. Never let anyone tell you that you can't do a thing just because you're too anything. You're too short, you're too tall, you're too old, you're too young. The word too, T-O-O, in fact, actually indicates inclusion. So never let anyone get away with telling you you can't do something because you are too something. Now, there are stories of female pirates in every culture, in every history. Not all of those who sailed the high seas, though, were pirates. Most of the folks view pirates as sailors who worked on board a privately owned ship, who on board would board, attack, control, and essentially steal everything, including the ship they boarded. And some of the folks who worked on the high seas were not privates, were not pirates, they were privateers. A privateer is a sailor working on board a privately owned ship with permission to board, attack, control, and essentially steal everything, including the ship that they were boarding. Permission is the important thing here. Permission was granted from the king or the queen to openly attack other ships, and then they wouldn't get in trouble for it. Essentially, it was legal piracy. This permission is called a letter of marque. I myself happen to have a letter of marque. It is written and signed by my supervisor to attack, take captive, destroy, and otherwise plunder all vessels sailing under the Casper ensigns for a period of time which would please Her Royal Majesty or until Rock Springs has defeated Casper should war occur. It is signed and it is sealed, and it is based on a letter of marque that was written from Queen Elizabeth. So this is actually based on a period document. Okay, rules. Everywhere has rules. Ships have rules too. These rules were different between ships, so when a new worker signed onto the ship, they agreed to follow the rules. We're going to talk a little bit about tools. One of the jobs on board a ship was the navigator. It's my favorite job. One of the cool things about being the navigator is if the ship were to be boarded and taken over, they did not kill the navigator. The navigator was protected because the navigator had knowledge of the maps and the tools needed to get the ship from point A to point B. Now, as a navigator, the sailor had to understand basic mathematics. Navigation on board a ship, of course, is all about where the ship is when there's no landmark to help. They use the stars as landmarks to navigate. This is called celestial navigation. The star chart that you see on the wall behind me is from the celestial navigation class this morning. I teach that class too. But you'd have to kind of stay up until dark for me to teach that class, and I'm pretty sure you would not be happy if we kept you that late. Celestial navigation requires the use of some tools. One of the tools is called an astrolabe. Astrolabe, this, let me get closer in. This was a gift from a friend, and it has inside of it several different discs. You take apart here. Inside the discs have different skies. It's not coming apart. Okay, so inside here is a storage for night sky discs from different skies. This is a fabulous, fabulous gift from a very dear friend. And my astrolabe of choice for this class because it's big and you can show it. Okay. Okay, so Owen has opened it, and inside are the discs from different night skies. So this is a very useful tool. Okay. So the navigation using the astrolabe often required use of a target star. This is usually the North Star or Polaris, and that is this one right here. Now, when I were a little tiny girl, my grandfather took me outside and showed me how to find the North Star. The North Star is, and it's not as easy as it sounds. We're familiar with the Big Dipper or Ursa Major. That's this one right here. You can see the four corners right here, and then the handle, which is right here. And that has a companion set called the Little Dipper, and it's right here. These four stars and the handle, also called Ursa Minor, because for some reason whoever named these constellations thought theirs had tails. If you allow liquid to pour from the ladle that is Big Dipper or Ursa Major out onto the handle of the Little Dipper, you will pour it onto the North Star. The North Star is not the brightest star in the sky. As a matter of fact, it's kind of it's really not one of the shinier ones. Okay, but so it was important to be able to find the North Star. Why is the North Star so important? Well, the North Star is the only star in our hemisphere that does not move. Everything else, all of the stars that you see, actually spin around Polaris, the North Star. And if you were to take a weight and a string and hang it on, see if I can do this, where the North Star is, when it reached the horizon, that's up here. There we go. If you were to hold the string and it weighted through to the north, through to the horizon, the nearest horizon would be due north, and that's how you could find north. Okay. On the resulting, okay, so Polaris is sighted using the edge of the astrolabe. Well, okay. And you would sight it by pointing the lever at Polaris and then the level with the horizon. And that way you could determine with some fairly simple mathematics where you are longitudinally on the map. Okay, so this is pretty important. It's pretty important to know where on the map that you are. Okay, with this information and the use of an astrolabe, sailors could navigate clear across the globe. They could find teeny tiny little islands to hide out on. You remember from the Pirates of the Caribbean, the island Tortuga that they talk about? It's a real place. It is 1 mile wide, it is 2 miles long, and you have to find that in the middle of the open ocean. So with an astrolabe and some star charts and the correct mathematics, you could find that teeny tiny little island. So this is really what allowed sailing to become a booming industry. Now, the tools of a sailor include a monocular. This is a reproduction, because I can't afford a real one, of a period monocular, and you focus it by twisting, by by moving the focus. Okay, so all navigators would have one of those so that they could keep track of things that they might be able to see on the horizon eventually. Okay, also every navigation kit had a bosun's whistle. Bosun's whistle is used to make different calls for communication throughout the ship. And Owen's going to shoot me. See, told you Owen would be unhappy. There are different calls that are associated with different things that you can do on a ship. Modern bugle calls are the same, are a similar thing. Okay, so the bosun's whistle was used for communication. There were 4 bosun's whistles that were found on the wreck of King Henry's ship, the Mary Rose. There were the remains of at least 4 of these bosun's whistles. Now, in addition, each ship had a sundial. Okay, and we have a sundial here because some of the readings need to be taken right at solar noon. And the sundial is used to know exactly where you are, the exact position of the sun, or the exact position relative to the sun at solar noon. So each ship had a sundial. Each ship also had a compass. Now, compasses are kind of an interesting thing. Now, anyone who intentionally damaged the ship's clocks or the ship's compasses were considered guilty of attempted murder, and they were typically immediately thrown overboard as food for the sharks with no remorse. Sorry, not sorry. Like any business, each person who works there had a specific job. Because the days were long and the sea was at sea, and there's little to keep people occupied, very often they cross-trained. Cross-training in other aspects of the work, which means most of your seafarers know math. Now, remember the accuracy needs to find this tiny little item? That mathematics is kind of important. In addition to navigation skills that were needed on shore, those same skills could be used on land, like on the sea voyage, like the seafarer's voyage. They used simple tools. I have a pocket astrolabe. Okay, it is similar to, but has only one hemisphere. Operates in the same way by folding the lever and then aligning it with the horizon. So this is another version of the astrolabe. Oh, in addition to this pocket navigating kit, I have a shepherd's watch or an Aquitaine watch. Okay, you can find these online, and they're not very expensive, but they're really fun to play with. As it turns out, this is called an Aquitaine watch because Eleanor of Aquitaine liked to have her husband home in time for dinner. Her husband, Henry, second of that name, really liked to hunt. So she commissioned in the mid-1100s to have this tool created for her. Along the edges are the months of the year. Where are we? There we are. Okay. So the months of the year, and this and the center ring that's brass that moves back and forth. The way you use this is to move the center ring to whatever number or whatever letter corresponds with the month of the year. This is May. And then next to it, there's a tiny hole. Hold it up to the sunlight. The sun will shine through that tiny hole into a series of numbers that are inside. The numbers that are inside. I don't know if you can see that. Okay. The numbers inside correspond with the hours on watch. This is an early wristwatch. With these tools, you can navigate your way to the important things like the house, the key. It's the key to my house, by the way. Really, the key to my house. Okay, so this pocket sundial allowed Henry to be home in time for supper and keep the marriage as happy as it could possibly be as far as arranged marriages go. It didn't end well for them. He ended up locking Eleanor on an island far, far away. That little pocket sundial, by the way, is surprisingly accurate. So on board ship, we have star charts, and these are star charts. This is a star chart from the Mediterranean. Oh, there we go. See, Mediterranean star chart. And then we have land charts. This is the map that Christopher Columbus was working from. So land maps and star charts are similar in varieties and similar in use, although what they depict are different things. A little cross learning here. The maps were created as accurately as they could possibly be, and then they were reproduced. They were reproduced using a technique called prick and pounce. What that is they would take an accurate map, they would poke holes at regular intervals along the lines on the map, and then they would take a chalk bag and they would pounce it over the holes and then play dot to dot. And that was how they reproduced maps as accurately as they could. Also a method used to transfer patterns onto fabric to use for embroidery and other reasons. So once the design was transferred, the dots were connected and it produced a really concise replica of the map. Now, before I go on, something I probably should have covered sooner. I want to caution the new folks and some of the folks who might have been involved in the SCA for a long time, not to fall into the trap of thinking that our medieval forebears were somehow less intelligent than we are in the modern era. Nothing could be further from the truth. Medieval people were as capable of observing phenomena in their natural environment, and they were probably a lot more likely to do so. I mean, okay, think about it. Those of you who might be under the age of, say, 35 have probably never been taught how to use a map and a compass for navigation. The only exception might be those who are prior military service. So if you've never used a map and compass to navigate, how do you get around? Most folks use a GPS. What happens when the battery on your GPS dies? Or the GPS malfunctions, or you drop your phone in the river and suddenly you no longer have a way to call for help and you no longer have your GPS to get you out of there. Were you paying enough attention to get yourself out of this situation and navigate your way back? Maybe, maybe not. The history of navigation is actually much longer than most reckon in the SCA time period to be. See, now I know that they have stated there's actually no beginning or early for SCA purposes, but most folks unofficially say anything earlier than about 650 AD is too early. Initially, people assumed that sailors just stayed within sight of the coast in order to keep track of local landmarks to know their position. And while this is certainly one way you can keep your bearings, we also know that our ancestors crossed the water and no land in sight, using only the stars and some of the basic tools we've talked about to get them safely and reliably across large bodies of water. We know from the archaeological record, for example, that the Minoans made sea-crossing voyages to the islands of Theta and to Egypt. We know that they arrived in Egypt. So the history of seafaring folks and the history of navigation are pretty much directly linked. The use of history and astronomy when paired with applied geometry, here we go with the math, trigonometry, and a few simple instruments have produced excellent sailors from the Polynesians, the ancient Greeks, the Romans, the Norse, the Chinese, the Venetians, the Portuguese, the Spanish, the English, the French, the Dutch, the Danes, among others. Celestial navigation is defined as simply as using stars to navigate. This includes that big, bright burning ball of gas billions of miles away that heats our planet and grows our food and lights our day. Navigation has been occurring since before there were written records. The first account that we have of using the stars to navigate come from Homer's Odyssey, when Calypso tells Odysseus to track the positions of the Pleiades and in the constellation of Orion, which you can't see on here because it's not in our current night sky. When she tells him to keep the Big Bear, or Ursa Major, to his left as he was leaving her island, she was giving him information. Ursa Major, the Big Bear, the Big Dipper, was particularly important since the location of Ursa Major and Ursa Minor are the keepers of the North Star. And that's why she was giving him the instructions in the Odyssey using those stars. Now, most of us as children were taught how to find the Big Dipper and the Little Dipper in the night sky. And contrary to popular belief, Polaris is not the biggest or the brightest. It's actually rather less shiny. That being said, it's called the North Star because it's the only star in this hemisphere that's actually stationary. Several tools have been developed across history to allow navigation. The Norse actually used a calcium carbonate stone called optical calcite. And I don't know if I can get close enough for you to see the fractures in it. There we go. See the lines in there? If you take this stone and you take it outside and you turn east to west or west to east, whichever you want, until the two lines, you'll see two images until they line up. When those two lines cross, that is either facing east, due east, or west, due west, solar east and west, depending on which direction the sun is coming from. If you have the sun at your back in the west, then it is facing east. Okay? And the Norse used this as a navigation stone. It's called the sunstone. It works with any light, including really low light or weak sunlight, what's really important if you have overcast skies a lot of the time. And by holding it with that was able to, with whatever sunlight, give you the idea or give you the indication of east and west. So we've got the North Star to tell us where the north is, and by default where the south is. We have a sunstone to tell us where east is or where west is. Okay, and these were used by the Norse and others to find their way around the wide oceans before there were any technology. Okay. Magnetic compass, by the way, we're talking about compasses. The magnetic compass was actually evolved out of China. What they discovered was if they took a magnetized iron ladle and they put it on a smooth brass tile and they spun it, the handle would always face south when it stopped. And this was the beginnings of the compass. You know, I don't know if folks, if this is an experiment that most of you did when we were kids. We would take a needle and rub it with a magnet so that the needle itself became magnetized, and then you floated it on a cork. You spin it and it would line up north and south. This is the same principle. So it would automatically align with the pole of the earth, indicating where north was. So by splitting the sphere, this earth that we're on, into 360 degrees, the thing that we know as a circle, along with detailed maps, it's possible to determine with surprising accuracy via land or sea. And dry compasses, like this one, okay, see if I can get it. This is an actual replica of the compass that was found in the wreck of the Mary Rose. And there were 4 of these that were found in that. So they had these as early as the 1300s. The compasses that, the magnetic compass that has the compass star in it. So that was available during our time period. So why are we using 360 degrees, especially for the circle? And that's complicated. Around 1500 BC, Egyptians divided the day into 24 hours. So you can blame the 24 hours on the Egyptians. Um, Greek astronomers then made those hours equal. So somewhere between about 300 BC and 100 BC, the Babylonians, whose numbering system is constructed on a base of 60, ours is on a base of 10. 360 determined that 360 can be divided evenly by 2, by 3, 4, 5, 6, 8, 9, 10, 12, 15, 18, and 20. So it makes the division of a circle into equal parts fairly easy mathematically. Essentially, it all boils down to mathematics. And if you get the opportunity to sit the introductory mathematics course, I would highly recommend it. Her Ladyship Sarah goes into some great detail about the base 60 numerical sequence, and it's quite worth your time if you get the opportunity. One of the earliest direct navigation tools is called a camal. Now, the camal comes to us from the Mediterranean. It is a simple piece of wood with a cord, okay? About 2 inches long. It's about an inch wide. They would put one end of the cord with a knot in their mouth, okay, and the other end would be on the North Star, and then the horizon. And they move the device until the bottom, as the top of the cord is on the North Star and the bottom is on the horizon. And then they tie a knot. Thereafter, as long as every time they put the end of that cord into their mouth and the top of the wood block is on the North Star and the bottom of the wood block is on the horizon, they are on the same degree of latitude, and they can just sail on that line until they get to until they get to the appropriate longitude, which they then figure out using the star charts and the mathematics, and they would turn directly perpendicular to their location, to their needed location. So that was how navigation was done. Okay. The ship could sail quite a ways on a single line of latitude, and then just turn 90 degrees, either north or south, and find their object using their star charts. So the charts were pretty important. Okay. Now the object of the ship is to sail on this line. Okay. Either east or west, and then turn north or south along the longitude from a line that is called the Greenwich mean latitude, Greenwich mean time. Okay. The location that you're at, any location on the globe, is figured, the time is figured from the Greenwich mean time. So, for example, where you're at, well, most of us, those in Atlantia, or those in Artemisia, those in Atlantia are 5 hours from Greenwich Mean Time. Those in the Middle Kingdom are 6 hours from the mean time. Those in Artemisia, we are 7 hours from the Greenwich Mean Time. That's the distance expressed in the time it takes for the sun to pass from one to the other from Greenwich Mean Time divided by 24. So the distance that it took for light, not the ship, but for light to pass in 1/24th of the day's time span is where they determined the lines of longitude to be. So, in order to know when the ship arrived at the desired longitude, requires a little bit of trigonometry and a little bit of star chart. To make this kind of easier, Rabbi Levi ben Gershon, a Jewish scholar who lived in Provence, France, developed a Jacob's staff. Jacob's staff, much like the Kamal, has a sliding piece. There's a cross member, and then the piece that slides up and down, and it works in the same way. You find Polaris, and you find the horizon, and you keep the distance on the Jacob staff the same distance. You could also use the distance discovery using your Jacob staff between two stars, and using some triangulation, determine where on the map your ship would be. I was able to pinpoint it on the map using lines of latitude and just a little bit of basic mathematics. So the star charts were pretty important. They were highly prized. They were closely guarded because without them, a lot of times the ship would be sailing blind. Those maps were closely guarded and rigorously defended because the calculations are fiddly. So fiddly, in fact, that we're not going to go into that in this class. I can teach it on another one. So with the Kamal and the Jacob staff, and later the sextant, they were all tools that could be used to determine our location on the planet. Each of these tools has is a type of astrolabe. Those the astrolabe used to determine the latitude, and we can make a simple one that you can use later to find a latitude in place. We're going to go very quickly through how to make your own. In order to make your own, you'll need simple school tools. You'll need a length of cord. Oh dear. And I put the scissors just a little bit too far out of reach. And you'll need a fishing weight. Add the fishing weight to one end of the cord. This used to be much easier back when I could see. So that the weight swings straight down. Okay, the other one is the hole that comes in the protractor. It comes automatically drilled in. And I'm just using the length of jute cord because the already drilled in hole will be at the 0 mark. When you hold your weight up, you can then look along this, the bottom edge, or now the top edge, and it becomes your sight glass. You aim your sight glass until it points at the North Star. You trap the string and the resulting degrees out of the 360 degrees will give you your latitude in degrees. So pretty handy, fun tool. Depending on where you are in the United States, for those who are in the Artemisia area, yours will be somewhere around between 40 and 43 degrees. So that's how you make your own pocket astrolabe, and they're once again surprisingly accurate given the sophistication of the existing tools. That's something that you can do to try this at home or with your kids. And those are the tools that I have for you guys. I'm going to go ahead and open it up, see if there are any questions. which will involve, Shelley, can you turn on mics, please?
Yes, I can.
Okay.
People can also unmute themselves. Feel free to unmute. That way, if somebody's surrounded by blenders, and then if there's anything in the chat, I'll read that off.
Okay. So, are there any questions regarding my simple tools?
They're cool.
They're cool.
You're cool.
That wasn't so much a question.
I love navigation.
I just had a quick question. Is there documentation for this class or a handout or anything where we can, those of us who may be multitasking, can see this stuff?
I do not have the handout for this class. I honestly, I was just going by the notes that I had to tell stories from, but I can get you the notes that I have to tell stories from if you just ping me on Facebook and give me an email address. I can send it to.
Thank you.
I am happy to help.
Malkin.
Yeah.
Uncle Bill.
Hey, Uncle Bill, what's up?
That block of wood you were using, you said put the top edge of it on the North Star. And then how do you, it's a 2-inch block of wood. How do you get to the horizon?
Perspective.
Pull it closer.
You slide the block up or back along the string until that's all you can see is
Okay.
the horizon and the North Star.
Okay.
You just tie a knot.
Okay, I got you. Now what do you do with the string after that? How do you get a longitude out of that?
You tie a knot, and thereafter, while you're sailing, you make sure that every time you look at the North Star and the horizon, that
Okay, I got it. I got it.
the horizon is at the bottom.
I got it.
It would be a relative longitude.
Yeah.
But you don't necessarily know from that it's 45.
Okay, I got you. Okay, thank you.
Someone said the Aquitaine watch is really interesting to me. Where would you suggest getting one from? The ones I found with a quick search don't look like yours.
Okay. I actually ordered it online from Amazon for like $12. That's where I got mine. And there are some cool ones, and the principle is the same. The ones that just have a hole in the ring will still give you accurate results without the slider. And they're really fun. And they're a little more manly than the one that I have that has kind of a flower border on it that is similar to the one that Henry had made for Eleanor because he liked his so much.
It might also be worthwhile to ask that question in the SCA Merchant Relief SCA Facebook group. Cool. Because I'm sure somebody's delighted to sell that one to you if you'd like to ask them.
Hadn't thought about that. That's awesome.
I have a question about the Mediterranean star chart you flashed up earlier.
Yes.
It's really pretty. Is it based on a period source?
It is based on, it's a copy of one that's found in a museum that's period. It is a period star chart. This one right here. Very pretty.
Yes, that one.
And I actually copied it off from one of the Maritime Museum websites.
Would you happen to remember which one?
I'd have to look it up. I actually did a research paper on this. I can go back into the research paper and get the website that I lifted it from. Once again, if you ping me on Facebook, I'll be happy to provide that information. I just need to find the research paper.
Somebody asked what is the link in the previous message. That once again is for attendance. If you want credit in the University of Artemisia, if you put your information there, it will magically appear, I don't know, tonight, tomorrow morning in the university records.
My map fell on the floor. Any additional questions? I think I left too much time for questions.
Well, that's okay. I was a little unclear on what you were doing with the protractor.
Okay.
and positioning the string to figure out
Okay.
degrees there.
Here we go. So, if you have a protractor, a lot of times you can buy these for less than $1. I think I got, you know, a dozen of these the last time I taught this class to a group of children for like $3. Along the business end are the numbers of the degrees in the circle. This is how they use it in school. There's also going to be a hole in the middle or at the 0 point for what we're going to do with it. I'm going to tie a string through that hole that is long enough to reach past the numbers,
Okay.
and then a weight. Okay. You take that apparatus, that astrolabe that you've made, and you sight from your eye here to Polaris here. And it will be at an angle. Here it'll be at an angle kind of like that. Okay, and I tell the kids, when the weight stops moving, trap it with your finger. And whatever that chord is at is your degrees of latitude.
Okay, I got it this time. Thank you.
Mm-hmm. It's a really fun experiment that you can take out to the field with kids and adults. I actually teach this class to a lot of kids in the summer as a part of my modern job. So
honestly, it feels like it should be more complicated than that.
And
that's exactly what it is. That's amazing, honestly.
Yeah,
do you know what the star is on the southern hemisphere that is used for a similar purpose?
They don't have one.
Oh, sadness.
Where their North Star would be or their South Star would be is a blank space or blank patch of sky seen with the naked eye. And there are some things that you can do to get south that involve using the Southern Cross, which is the 4 stars that you see that look kind of like a diamond shape in the southern sky. But it's kind of complex.
But I'm sorry, did you just say, was that the Southern Cross you said?
Yeah.
Okay, I've heard that term. So in there is where it would be, and that's probably why people care about the Southern Cross.
Yeah.
Also the most, if I might add something, if you wish to do a similar form of very, very rough identification of latitude, and you don't happen to have any protractors or pieces of wood or something, you can actually use your own hand. This would be 1 degree, this would be 10 degrees, this would be 20 degrees. You set it up with 1 anchor point against the horizon, and you go up to the North Star, and you can do a very rough estimation just doing that.
Okay, Amanda, give me just a second. I actually have it dedicated to me. I'm going to have to find
Yeah, I had to switch over to you as well. Here, hold on. I'm going to highlight you for a second.
Yeah.
Spotlight. Okay, it's you. Can you do that again?
Do it again.
Okay, I'll do it again. If you don't happen to have any of those other devices and you do need to do a very rough estimation of your latitude, you can actually use your own hand, because this is approximately 1 degree. This is about 10. This is about 20. You anchor one portion, your thumb, at the horizon, and then you literally climb up until you match up with the North Star, and you will actually get a fairly accurate, within about 2 degrees of where you're at.
Are you holding a specific distance away, just arm's length, or?
Just you're holding it out, and it's literally anchored up. And it's a very rough method, but it will get you within a few degrees.
Definitely to tell the difference between, you know.
But at least enough for a rough.
Very cool. I did not know that one. I'm going to add that now.
All right, I'm unspotlighting you. As soon as I can remember how to do that. It may take a while. Oh, there we go.
That's okay. I'm kind of struggling with the Zoom myself.
All right. Well, it's 10 minutes until 3 o'clock-ish. So if folks are done, I'll hit cancel on the recording, but if there are any other questions?
I have one last quick question. You mentioned we could find you on Facebook. How do we do that?
Oh, that's right. I changed my name. I'm sorry. On Facebook, I am J.O. Foster. And the location that you'll need to find me is Rock Springs, Wyoming. So if you find Joe Foster in Rock Springs, Wyoming, that's me.
Thank you very much.
Thank you, Malkin. This class has been wonderful, and I'm so glad that you did this.
I'm glad you had fun. This is actually one of my favorite classes.
This was fabulous. Thank you.
Thank you, Malkin.
Thanks, guys.